Good day, ladies and gentlemen. This is Glenn Tan speaking. This time, we're going to talk about air-cooled screw chiller, the troubleshooting. This presentation divided into these three parts. First, I will introduce the cycles, including the refrigerant and water cycle. After that, in the second part, I will introduce the basic operating logic. The last, I will introduce the detailed troubleshooting. This is the cycles. On the left side, this part is the refrigerant cycle, and the right side is the water cycle. So on the refrigerant cycle, you can find that we have the compressor, oil separator, and this is the outdoor heat exchanger, Q and fin. After that, we will have the dry filter, and then this is the preheat exchanger as a subcooler, and this is the evaporator, and then you can also find that this is the oil return, and this also we have different pipes for the compressor for different functions. So I will analyze first is for the cooling. The refrigerant from the compressor is high pressure and temperature gas. Then after the oil separator, it will go to the condenser, which is the outdoor heat exchanger to release heat. Then the gas become liquid and gets through this dry filter. After that, it gets through this preheat exchanger. Then get to this EXV1. Then it will get expanded to become low pressure and temperature liquid. Then get into this evaporator to become gas, which is to absorb heat to doing cooling, to cool down the water. After that, the gas, this refrigerant gas will get into the compressor to finish the travel. And if we find that it is too hot of the compressor, so it will conduct the refrigerant from here directly, and then it will get through this ESV2 and also get expanded to become low pressure liquid. Then we can spread this low temperature liquid on the suction shaft of the compressor to cool down the compressor. And also for this ESV3, it is for the two-stage compress, which is just the refrigerant will flow like this. A partial refrigerant will get through this EXV3 and get expanded, then become low pressure, then it can absorb heat from the main rod. Then this one will become gas, right? And then we inject this gas into the compressor for second stage compress. This is to higher the system capacity and also the performance. And this is for the refrigerant cycle. For the water cycle, you can find that this is the water pump, and after that you get into the evaporator to cool it down, which will become chill water. Then we can send the chill water to the FCUs and also equipped with this expansion tank. And here is how the water flow from the water pump. Then we send it to the evaporator to cool it down. It becomes chilled, and then we send the chilled water to FCU. Then the temperature will become higher, then flow back to the evaporator. And for the heat pump type, you can find it. It's similar to the cooling OLED, and we just have this device. It is a four-way valve, and for the water cycle, it's completely the same. The difference is just we add this device. And I will also analyze how the refrigerant flow in the heating cycle. And the refrigerant from the compressor, after it goes through the oil separator and four-way valve, then we first go to this heat exchanger, which is to release heat from gas to liquid, and then get expanded at this ESV1 and become low pressure and temperature. Then it will get heat, which is to absorb heat at the outdoor heat exchanger, this device, and then become gas, and after the boil well, then to the compressor, this one. And if I and this is for the second stage compress. Also a partial refrigerant from the make roll to get through this ESV3, and then absorb heat from the make roll. Then itself will become gas. Then we inject this gas into the compressor for compression. And also for the water cycle is the same. We just send the water to this tube and shoe, and then it become hot. Then we send this hot water to the FCU to do heating. Then we get the warm water from it and back to the water pump. And let's recognize the components inside. And this is the side view of the air-cooled screw chiller, and this is the top view. So you can find that this part is the condenser fans inside, and this is the fin and tube, and this one is the compressor. So you can find that there are two compressors of this chiller, and this one is the evaporator. It's fluffy type, which is this device. And also this is the oil separator. This one also the oil separator, and the EXV located here. And for the evaporator, we need the pipe the water in and out from here. And also don't forget the economizer, which is the preheat exchanger located here. And at this side is the weak current control box, and this is the strong current control box. Also at the evaporator in and out, you can find that here is the flow switch. And also there are two sensors. One is to check the water out, and also the other is to check the freezing. As for the strong current control box, and here is the appearance, and this is the emergency stop button, and also with the indicators to show you the operating, and also is there any error. And this is the main switch to turn on or turn off the chiller. After that, open this one, we have the inside, and also you can find that a little bit too many components. So we will just locate it, just follow this. And as for the on-off compressor, which we mainly apply the delta startup method. And the purpose of this one is just to lower the startup current with the same voltage, which means we don't change the power input, just change the wiring of the compressor to lower the startup current. And here is the startup condition to mix all these five. Then the system allow the compressor to start up, which is including the water pump operate at least 3 minutes, and compressor stop at least 10 minutes. And also the setting temperature, it should be higher than the water out temperature. And also the water out temperature change rate is less than the preset value, which means it will not cool down quickly or the temperature change quickly. And the last is there's no malfunction. And here I will show you the star connection and the delta connection just to lower the current. And how to achieve it is at the start connection, if the current we just follow like this, 1 and 2 for the UV, and also for the UW, also coil 1 and coil 2. So the voltage no change, but the resistance there are 2, right? So the current should be less. And for the delta, also we will change it like this. And also for the U to V, there is only coil 1. For U and W, also only coil 2. That means the voltage no change, but the resistance is less. Then we can get a higher current, which is in the stable operation. We need to apply this connection. And for this one, and I also put the main components on here, so it can help you to recognize the components. This slide displays how the compressor turn on and turn off conditions, including three conditions. For example, in cooling, and first is the temperature, which is the water leaving temperature. It should be higher than the second temperature plus 2.8 degrees. Then this is clear. We allow to turn on, and here is the off. For example, in a two compressor model, and also depending on the water leaving temperature. If it is less than, and for this one, number 2 compressor less than the second temperature minus the preset value, for example 1 degree, then we will turn off the number 2. And if this water leaving temperature keep lower, which is lower than minus 2 degree, then we can turn off the number 1 compressor. And this is the temperature condition. As for the time interval condition, and for this one, the compressor should stop at least 10 minutes, then it is allowed to turn on. And when the compressor turn on, at least it should operate at least 6 minutes, and then we allow to stop. And of course, during this 6 minutes, if there is the malfunction, just like the high pressure protection, this compressor will stop immediately. And the last is the loading requirement, which means we need to change the slider position or change the compressor RPM for the inverter model. And for the loading condition, and for compressor to start up, when to start up this one is when we detected the load of the compressor 1 is higher than 45%, then we can turn on the compressor 2 to lower the output. And then for the stop condition, and also you can find that for this compressor 2, it is for both compressor actual load is less than 40%, and for this one we can turn off the number 2 compressor. And for the whole system to stop, it is when we detected the actual load is less than the minute load setting, like 10%, then we can stop the chiller completely. This slide displays how to control the slider position. And the purpose of this one is for the compressor, which is according to the actual load, which if it change, then according to that, we need to change the compressor output to meet the load, to avoid the water temperature fluctuate a lot. So we have two targets. First is our water setting temperature, to avoid it to fluctuate a lot. And then the second is the temperature change rate, also not too fast, to keep it to be slowly change. And first, I will show you how this slide change position. And this is the compressor. The green one, which is this one, is the slider. We change the position by the oil, which means the oil is not only for the compressor for lubrication, but also we can apply it to change the slider position. And first I will display this is the oil from the water tank here to offer to the compressor for lubrication. And then if we need the system required to loading, then we can conduct the oil which is from here through a solenoid valve, this one, then to the it here to push this slider which is to loading. But before that, we need to meet all these 5 conditions at the same time to avoid the system become malfunction and also to ensure the customer comfortable. And here is the loading condition. And when we require or the system require to unloading, also we need to which is to conduct this oil to going out, right? So we also conduct another solenoid valve which is to conduct this oil back to the here, and then also then back to the oil tank, which is to make this slider go back. And different to the loading condition, for the unloading, just we need to meet any of the following condition is okay, which means unloading is quite easier than the loading. This is also to ensure the system is not working too off frequently, or the condition if it meets the protection. Also we need to lower the system load or lower the compressor output. This slide displays how to control the fan. The fan refers to the outdoor fan that located here. And also you can find that for the air-cooled screw chiller, there are lots of the outdoor fans, right? And we divide it into different groups. And also the control is for cooling mode is just like this. It will be before the compressor turn on 10 seconds, then we will start up one group, and after that we will based on our desired high pressure, we need to maintain it in to our desired range, then which is the A and B. And if it is less than A, that means the high pressure is too low, so we need to turn off the one group of the outdoor fans and to higher the pressure. And if it is higher than B, that means the high pressure is too high, so we need to add another group to release more heat. And how to do the group separation is according to the different wiring diagram. As for the heating mode, then there are we need to wait the four-way valve change direction, and the four-way valve change direction condition is just like this. If we need to wait until the compressor turn on, then we can apply on the pressure difference to push the four-way valve, just like this. And also after that, we can turn on the fans. As for the off condition, it is to protect the compressor. We will wait until the compressor turns off completely, which means 30 seconds later, then we will turn off the fans. Next, we will go to the main EXV control. We divide it into basic and protected control. For the basic control, it is before the compressor turn on, the EXV will open to the initial degree and maintain for the initial time. And after that, which is after the compressor turn on, will according to the superheat of the compressor suction to adjust the detail opening, because we have the low pressure and also the compressor suction temperature, so we can get the superheat of compressor suction side. And for the protective control, it's also to ensure the system is maintained in our desired range. For example, if we detected the compressor superheat is too low, we will turn load down, which is close the EXV. And here is a summarize for the startup sequence. So for the cooling, it is first we will turn on the water pump. After that, turn on or make it to be initiate opening for the ESV. After that is the fan, and last is the compressor. And here is the cooling, and this is the heating. And do you know why it is different between the cooling and heating, especially for the fans? This one and this one. And the reason is that we need to push this four-way valve because it is rely on the system pressure difference to push the four-way valve slider. So we must wait until the compressor turn on, which we and operate for a little while. Then we can get enough pressure difference to ensure the enough force to push the four-way valve slider. Next, we will go to the detailed troubleshooting.
First of all, what is error? And actually in the chiller system, we always keep monitor every important parameter like the compressor discharge temperature and the pressure and also the outdoor temperature. And for this one, we always we adjust the components setting like the compressor or the outdoor fan RPM and even the ESV opening to keep above, which is the our important parameter. We make sure it is in the desired range. And just like this, for example, we have for every important parameter, we already set up the regular control zone and also the protective control zone. And for example, we take the compressor discharge temperature, for example, and if it is higher into this protected zone, we will adjust the parameter like to decrease the compressor RPM or to higher the EXV opening to make it to going down. And next time, if it is lower than the regular lower limit, we always adjust the parameter to make it a bit higher. And once it is in this zone, the system will not do any protected control to do that. But if it out of this protected zone, the system will have no idea but just shut down and display the error code, which is E4.
And how can we check and operate the parameter and states? And also you can check the error code for the operating parameter from the Y controller. And according to different type of the air-cooled screw chiller, we have different Y controller, but the function is almost the same. And also we will display all the parameters and text and detected value directly to you. And also you can also check the error code on the PCB, which is here, this one. And as for what is the meaning of the error code, you can rely on the Y controller. Then we will not only show you the error code, but we also show you what is the error of it. And also you can rely on the service menu or the owner's menu. Then we also listed the meaning of this error code there. This is the maintenance tools you may use during the troubleshooting, including the multimeter and keep time ammeter and the refrigerant leakage detector pump. This is to check the water system leakage or the water system pressure, and the pressure gauge, spanner, pipe wrench, and screwdriver, and also the megameter.
First is the temperature sensor. We also call it thermistor. Actually, the temperature sensor, it is just a resistance, but it is the value is very sensitive to the temperature, which means if the temperature change also leads to the resistance value change. Then for the PCB, we always use the voltage to check it, which means the voltage also change. Then the PCB can get the temperature information. And based on that, the system will change the component parameter. And inside the chiller, there are 3 types of the sensors, which is the 15K ohm. It is for the high temperature, which is the compressor discharge pipe, and the 50K ohm. It is for the low temperature, which means the outdoor ambient temperature. And the last is the 20K ohm to check the tube and also the water. And also you can find it. This is the relation between the resistance value and the temperature sensor. And also you can find it. We always use this part to check the resistance and also the temperature, which means it is more sensitive, right? So this is the reason why we need to have 3 types of the sensors, because the sensitivity is different. And why we call it 15K ohm or the 20K ohm is based on when the temperature is 25 degrees and the detected resistance value, if it is 15, just like this is the 15K ohm sensor.
This slide displays an example for the system how to use the temperature sensor, which is the compressor. And as you know that we should avoid the compressor to be overheat, as the high temperature will lead to the inside oil to be decomposed, which may shorten the compressor lifespan. And on the system also you can find it, especially at the compressor discharge, which is the hottest one. We put the temperature sensor on it. It is the discharge pipe here. And also based on the temperature in the control logic, we also set it when the detected temperature is higher than, for example, 90 degrees, we need to increase the EXV opening to conduct more refrigerant to flow back to the compressor to cool down. And if it's higher than 95 degrees, and then we will turn on the liquid injection, which is to cool down the compressor by the liquid refrigerant. And if it's higher than 100, then we need to reduce or to decrease the compressor RPM, but this is for inverter only. And if it's higher than 110, we have no idea, but just shut down the compressor or the system for protection. And this is the detail when we have this temperature sensor malfunction, which is the sensor is open circuit or short circuit for a preset period, for example 5 seconds. Then the system will treat this error, which is the AD value. Is this the design range? And here is the detail. First, how to check is we connect the sensor to the PCB. We're just afraid that maybe this connector is not connected that good, also leads to this malfunction. Or next is to check the resistance value. Just compare with the standard one. If it is almost the same, that means it is okay. But this is not that easy to, especially to memorize the standard value. So here is how we do in China. And for the service person, we always bring a good one with it, and then we just put a good one near to the suspicious one. Just compare the resistance of these two. Then we can get the resistance value. If this difference is not that large, that means this sensor is okay. Otherwise, you need to change it. So with this one, we don't even need to know the temperature. Just compare the resistance value. It's okay. And the last one is maybe something wrong with the detected cycle, which means the PCB. This one is malfunction. And after that, we will go to the pressure sensor. As you know that the pressure is almost the same as the temperature. We just change the detected target from the temperature to the pressure. And all the inside the conduction is almost the same, which means the PCB can receive the pressure information and based on that to adjust the components to ensure the system reliability. And the error judgment is the sensor, which is the pressure sensor, is open circuit or short circuit for 5 seconds, which means the AD value is the desired range. And also you can double check or double confirm from the detected parameter from the Y controller. You can see that here means this one is high or low pressure is out of the desired range. And also similar to the temperature sensor, first is we connect the sensor to the PCB. We're just afraid maybe this one is something wrong, is not good connected. And after that is just compare the pressure which is detected from the pressure gauge and compare with the this AD value. If there's no two difference, that means this sensor is okay. And after that, something wrong with this PCB, which means the detected circuit is malfunction. Next, we'll go to the outdoor fan motor error, including EF, fan overcurrent protection, and H3, motor over temperature protection. As we know that the chiller just applied the circuit breaker and contactor to control the outdoor fans. So for these errors, we need to check the fan input voltage of the circuit breaker and the contactor output, which means we need to check whether the fan motor can get the power from the device. After that, we're just afraid that maybe the wiring is not that good, so we need to double check, which is to reconnect the fan wiring to this device to ensure it is good connected. And if it is still not fixed, we're just afraid that maybe the fan motor is malfunction. So just to replace a new fan motor to check it is okay. Next, we will go to the compressor malfunction, including H3 compressor internal protection and E5 compressor overcurrent protection. And here is the possible reasons. So when you encounter the compressor malfunction, and first you need to check the power supply. We are afraid that maybe the voltage it is too low, which leads to the higher current, and higher current indicates the E5 overcurrent. And after that, please check the three phases current value, just like this, to ensure there is no unbalance. And during operation, next is if you heard any abnormal noise of the compressor, also you can ensure or to confirm that the compressor is malfunction. And the next is the built-in thermal relay malfunction or poor connected, and this one located here. So on site, you just need to ensure the first is the wiring is okay, and then just ensure this one is in good state. And Next is the compressor unloading malfunction. For this one is the unloading valve. This is a malfunction, and next I will have a detailed slide to explain this. And next is compressor burn down. If the compressor burn down, we're just afraid that maybe the inside coil it is open circuit or short circuit. So on side you just need to check, and this one just follow this. This is the how to check it. This is the compressor. Here is the UVW. And when the compressor burns down, we're just afraid that the inside coil, which is this coil, it is open circuit or short circuit. So on site, you just need to ensure to check the resistance of this. First, this one, ensure it is not short circuit. And also to check the isolation resistance. Basically, it should be higher than 10 mega ohm. And the next is compressor lockdown. And for this one, we divide it into the refrigerant and the oil system. And first is the oil system. Just focus on the repair system. And for this one, that means not enough oil to flow back to the compressor for lubrication. And just because of this, the compressor will cost more power to operate. And more power means the higher current, right? So you need to check is there the oil can flow back to compressor for lubrication, especially from the oil separator. And it's for the refrigerant system. We're just afraid that maybe there's some blockage or leads to the when the compressor operates, it leads to the higher delta P, and higher delta P indicates will cost more power to operate, and higher power always higher current. And if it is locked down, you can also check it at the startup period, which is to check the high and low pressure. If it change a lot, that means it is not locked down. If it is almost no change, that is locked down. And last is we just afraid that maybe the current transformer it is malfunction. So on site also you can check the display value on the screen and also compare with the value you just use this meter to check whether it is almost the same to ensure the current transformer is okay. Next, we will go to the low oil level protection E3. And first is the error judgment, which is after 90 seconds of the compressor start up, if we detected the oil level switch is open circuit, then we will trigger this error. And where is the oil level switch? Is located here. This is the compressor. And for the first 2 times within 1 hour, it can recover automatically. After that, the system will lock down from try again. And here is the possible reasons. First, we will analyze the oil return passes. And this is the compressor, and this is the oil separator. And from the operation, and the oil and high pressure gas mixture will go through this oil separator, and the refrigerant will go into the system the upper side, and the oil will flow this process to flow back to the compressor suction side. And so for this error, that means the oil it cannot flow back here to the compressor. And the reason, of course, first is to check whether the cut-off valve or the solenoid valve, whether it is open or not. And after that, maybe this oil filter its malfunction also leads to not fully flow of the oil. And next is maybe this oil return process is stung or blockaged by the impurities. So you can also check from the side glasses. And on that, if you can see the oil flow, that means it is okay. And the next is maybe the system charged too much refrigerant. And you may ask that just too much refrigerant, what's the effect to the oil? That means if there are too much refrigerant, the compressor will become low superheat degree, which means it intake too much liquid refrigerant here, and this discharge temperature is not that high. Also, in the case it contains a little bit the liquid refrigerant, and this liquid refrigerant will absorb with the oil, and which flow back to here together with the oil, and also it can dilute the oil and makes the oil not enough at here, which indicates or which trigger the low pressure, low oil level protection. And for the last one is the oil leakage, and also this is only for the repair system. Next, we will go to the flow switch protection, and here is the error judgment, and which is this one, the water flow switch located at the water out, and then the detected water flow is less than the preset value, which is lower than this, the trigger this one, and then it will trigger this error. And here is the possible reason. Maybe this one connected to the PCB, the connection or the wiring is not that good, is to malfunction. And or maybe the water pump is abnormal, leads to the water flow rate not enough. Or maybe there's some blockage by the filter on the water system. Or actually the water volume is itself is not enough, also leads to this malfunction. Or maybe too much air inside the water system. At that time, you need to check the water pressure gauge. You can find that the pointer it fluctuates a lot. That means the too much air inside the system. And also here I will also show you a case. And on this case, you will find that this is the FCU, and sometimes you need to equip with this bypass valve. The reason for this one is if some FCUs, which is this one, miss the setting temperature, then if you equip with this two-way valve, then it will turn it off. So on the water system, it will higher the water system flow resistance, then for the water flow rate it will actually lower, right? And at that time, if without this one, the detected is on the water out of the chiller, so also the water flow rate also not enough, it will trigger this one. If you have this bypass valve, then the water system, if it will detect the water resistance is too high, then we will conduct this to open to ensure the water flow rate not change a lot, also ensure not trigger this water flow switch. And here is the detail, and maybe this flow switch on the PCB the connection is not that good, or to the water pump abnormal, so you can check the water pump to check the noise or the vibration of this one is there, and also this pump, is there any abnormal temperature rise. If too much air inside the water system, and you will find on the pressure gauge that the pointer, this one, will fluctuate a lot. That means too much water inside it. At that time, you need to open the bend pipe to release the trapped air inside. And the next is the water system blockage, including the filter and also the check valve. And maybe for this one, the inside coil it is a malfunction, and as for the check valve, also need to check whether it can conduct it or not. And this is how the check valve operates. Next, we will go to the low water flow rate protection. And for this error, it is similar to the water flow switch and also indicates the water flow rate is not enough, but this time it is triggered by the temperature difference between the water in and out. And if it is higher than our preset value, for example 8 degree, also it will trigger this error. That indicates the water flow rate not enough. And here is the possible reasons, also similar to the water flow switch, which is the first you need to check whether it is true or not by checking the water in and out temperature sensor, whether it is malfunction or not. And then the water pump and the water flow rate or the volume is not enough, and maybe the system is a blockage in the filter or the check valve, and maybe there are too much air in the water system, also may lead to this error. Next, we will go to the differential pressure protection E7. And first of all, what is the differential pressure? And that is on this is the pH diagram. And from this one, you can find it. This is the low pressure, and here is the high pressure, and this is the outdoor and bin. This is the chill water temperature. The differential pressure protection, that means this high and low pressure, the difference is too small, and for the system operation efficiency, the small of this difference is better, right? But if it is to the oil, it cannot circulate enough, because for the oil return, especially for this one, with the oil will flow back to the suction side. The power is the difference of the pressure, and if it is not high enough, we will not have enough power to push the oil, which is from the oil separator, to flow back to the suction side. And then sooner or later, the compressor itself will be short of oil. So to prevent this, we also set up this lower limit of the differential pressure. And here is the reasons why this error happened. First is the pressure sensor malfunction, the same as previous I introduced. Just follow it to check it, it's okay. And next is maybe the compressor loading or uploading valve is a malfunction. It's to not enough oil to flow back, or not enough power inside it. And next is the condenser pressure too low. That means the outdoor ambient temperature, this one, is too low, but is still required to do cooling. Then it for the system is very good, but for the oil return is not that. And the next is the evaporating pressure is too high. That means for the chill water, for this one, the temperature is too high, if out of the desired range, and then also leads to this low differential pressure protection. And here is the troubleshooting, and the first one is to check the pressure sensor whether it's good or not, the same as previous, so we can skip. And the next is to check the compressor loading and uploading valve. And next is to ensure the system, which is the outdoor and bin, it is within our desired range. And the last is the to lower the chill water temperature, and this is in cooling mode. The message you can lower the flow rate to ensure it is okay. Next, we'll go to the high pressure protection E1, and here is the error judgment. That means we get the signal from the high pressure switch. It is higher than the preset value, then also we trigger this error. Or this high pressure switch is poor connection or malfunction. So for the possible reason, first of all is to check whether the pressure is really so high or not. And you can also compare with your detected pressure gauge or to check the pressure switch. And then we divided the reason into the reference cycle. For this one, if this error occurs within the compressor startup 15 minutes, then you need to focus on the refrigerant cycle to check it why the accumulated so much refrigerant at the condensing side. And after 15 minutes, we focus on the water cycle, which is why not enough capacity, including the water flow rate and temperature at condensing side. And I put it on the cycles for better analyze. Also, left side is the refrigerant cycle, right side is the water cycle. And first we need to check the refrigerant cycle for the compressor start up within 15 minutes. And then the checking item is this. First is to check whether the high pressure is really so high or not, which is the high pressure switch malfunction or poor connection. And then just focus on the condensing side and whether the ventilation is not that good, to check the heat exchanger whether it is too dirty or not, or the fans ensure the ventilation. And also the tilt sensor, it should be good contact with the pipe, or maybe there are too much refrigerant inside the system, and of course this is only for the repaired system. And next is the discharge cut off valve. If it existed, it is not fully open, also this to this E1. And the last is the system abnormal like blockage. Here is the detail. First is to check the high pressure switch or the sensor whether it is malfunction or poor connected. And for the switch, just check the conduction. And for the sensor, just the same as previous to compare with the pressure gauge and the display value. And then to check the ventilation, including the fans, and this is for cooling. And also for heating, you need to check the FCU, the ventilation, whether it is good or not, and also ensure the temperature sensor, it should be good contact with the tube or pipe. As for the blockage or the stung, just focus on the dry filter and the EXV, especially when the temperature change a lot, then there must be a blockage. And here is for how to check the EXV. And first is to check the wiring to the EXV control board, and then to check the wire of the EXV, which is afraid that maybe just like this one, it is open circuit. And also you can make the whole system to be reset the power to check the EXV, the vibration, and you will hear tuck 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 tuck. That means the cord can join the inside pin. If it stung and always there's two phenomena, which is almost no flow. That means the stung or the jam is happen when the pin inside is at low pulse, and at that time just the impurity jam this flow. And the next is it is the control out of control. That means the jam or the impurity is at the high pulse. And the countermeasure of this one is just like for the residential air conditioner, to use your screwdriver to hit this EXV body, or maybe for 70% it can be flow out. And after that you can also ensure there's the stung here or the impurity jam here, then you need to replace this one. Next is low superheat degree protection. It is for the compressor, and here is the judgment, which is the difference between discharge temperature and the high pressure value. This too is lower than the preset value, for example 15 degree. Also, it indicates the compressor intake too much liquid. To protect the compressor, we need to shut down, and which is also for the compressor to avoid the liquid hammer damage. And on the system, you can also find that here is the high pressure sensor, and this is the compressor discharge temperature sensor. So first of all, you need to check whether the superheat of the compressor discharge is really so low or not by check these two. And then we maybe the main VSV it is stuck or blockage at the higher parts, which means we release too much refrigerant to flow back to the evaporator, and then from there to flow back to the compressor. Or maybe the liquid injection EXV, which is just to cool down the compressor, also stuck at high parts. Also leads to too much liquid refrigerant to flow back to the compressor to cool it down, but this time is too much. Also leads to the compressor low superheat degree. And after 15 minutes, just focus on the water cycle, which is on the right side, this part. So for this part, the check-in item is including the water temperature or the outdoor ambient temperature, whether it is within the desired range or not, and maybe too much air inside the system. At that time, you need to check the pressure gauge to check the pointer whether it fluctuates a lot or not. Or maybe the water flow rate is not enough. At that time, you need to check the water in and out temperature. If this difference is higher than 8, that means the water flow rate is not enough. And next is to check the difference between the high and low pressure to the water out temperature. If this is higher than 5, that means the too much water escape or the alert gate is inside. And here is the detail. And first is to compare the water temperature and the outdoor ambient temperature, whether it's within the range or not. And also this value has its meaning, especially for the water side. So first, and for this water in and out, and it should be within this range. If it is higher than A, what does it indicate? And what about lower than 2.5? What does it indicate? And also for the water leaving temperature, if it is less than 5, what does it mean? And here, higher than 8, that means the water flow rate not enough. And of course, lower than 2.5, that means the water flow rate is too much. It relates to the water pump low efficiency. And at this one, if it is lower than 5 degrees, it relates to the water frozen protection. And for this one, maybe the water flow rate not enough, or the chill water load is too small. And the next is the difference between the high or low pressure and the water out temperature. For cooling, it is just compare the low pressure and the water out. For heating, compare the high pressure and the water out. If this difference is higher than 5, that means too much water escape or the alligator inside. Just like this picture indicates, you can find that this heat exchanger is too dirty or too much water escape inside. And here you can find it. Here we just give you some experiments. If this value less than 3, that means almost no scale. And if within this range, that means the scale existed but not that severe. And if it is higher than 5, that means too much scale. And the solution for this one is just to clean it with either with the mechanical or the chemical methods. Next, we will go to the low pressure protection E3. And E3 is similar to E1, but this time is triggered by the low pressure switch, which means the detected pressure at lower side is lower than the preset value in the switch, or the low pressure switch is poor connected or malfunction. And here is the possible reason. First of all, to check whether the pressure is really so low or not. And then after that, also similar to E1, within the compressor start at 15 minutes. If this E3 occurs, we need to focus on the refrigerant cycle to check why there is not enough refrigerant at evaporating side. And after 15 minutes, we need to focus on the water cycle to check why there's not enough capacity. Is the water flow rate not enough, or the water temperature, or the outdoor ambient temperature at evaporating side? And next we will go to high discharge temperature protection E4, and this error is similar or very related to E3. The reason is that the compressor cannot intake enough refrigerant to cool it down. For that time, the discharge temperature will become very high, higher than our preset value, and also trigger this error. And at that time, you need to check why there is not enough refrigerant at evaporating side, which is at the compressor suction side. And here is the screw compressor sectional view, and the refrigerant intake from here and discharge at this side. And like this, here is the low temperature, and after this screw will become high pressure, and we just use this low pressure for an temperature refrigerant to cool down the motor, which is this part. After this one will become hot, and the reason for this error is the discharge of the compressor, which is the refrigerant, is too high. That means the inside motor is overheat, and overheat will also lead to the inside oil to be decomposed. So to check this error, first of all, you need to check whether the discharge temperature is really so high or not by checking the temperature sensor, and the method I already introduced in the previous stage. And the next is just focus on the refrigerant cycle and to check whether and why there is not enough refrigerant at the compressor suction side, which is the evaporating side. And here is the detail for the E3 and E4. And even as a designer, we can not predict which error will come out first, as the reason is that we cannot inject enough refrigerant at the compressor suction side. So it leads to either the suction pressure is too low, or the discharge temperature is too high. And I also divided into the refrigerant cycle and the water cycle, and the checking item is similar as previous. Here is the checking of the E3 and E4, and even as a designer, we cannot predict which error will come up first, because both of this error, the reason is the same, which is the compressor cannot inject enough refrigerant at the suction side, and this will lead to either the pressure is too low at suction side, or at the discharge the temperature is too high. So to analyze this one, The checking item is to check whether the trigger is really so high or so low, and which is to check the pressure switch, to check the conduction, and also for the sensor to check the resistance value, and also to check whether it had good contact with the PCB or not. And the other one is just afraid that maybe there's some refrigerant leakage leads to the refrigerant not enough. So with this one, you can use this refrigerant leakage detector, this device, and also you can check the oil spot. And as you know that the refrigerant and the oil, they are mixed together, and if there's some leakage, the refrigerant will become gas and flow out, but the oil it always remains, which means on side, if you have seen most of the oil on the surface of the tube and also on the surface of the chiller, you can also confirm that there's the leakage. And also you can use the soft water to check it. Next reason is the compressor unloading malfunction. And what is this means is this is the compressor. When in low condition, the system requires the compressor to lower the output, which is to lower the slider position. And then due to the malfunction of the unloading valve, the compressor still remain at higher output, also leads to the low pressure protection. And on side, this is the compressor, and this too is the loading and unloading valve. It is a solenoid valve, and which means when we get the power, it will conduct the oil to flow, just like this. And you can see that this is the pin and the moving part and the spring. When you get the power, it can make this pin up, and then the oil can flow through, which is to conduct unloading. So you need to check why it is unloading malfunction. And first is the power supply for this valve, whether it is abnormal or not, to check whether it can get the power. And the next is the oil is installed okay or not. And the next is the oil is maybe short circuit or open circuit, which means there's no magnetic force. So on the side also you can check whether there is the magnetic force existed or not to confirm. And the last is maybe the pin, which is this one, is stung by the impurities, which the oil cannot flow through. Also on site you can check whether this one it is actually it should be warm, and this one, if it is not connected, it will not be warm. So from here you can also check whether this valve is malfunction or not. And for this one, we also just afraid that maybe the liquid injection, which is this device, you can also find that we just use this solenoid valve and divide it, which this is come from the liquid refrigerant. We send it to the EXV, and then from there it will get expanded and spread into the compressor. We're just afraid that maybe either of this one is stung or blockage, so you need to check it. And also the checking item for EXV I already introduced is the same. And for the liquid injection condition, and here is just for your reference, how and when we will turn on the EXV and close. That's all for the troubleshooting. If you still have any other question, you can just feel free to contact me on this email address. See you.